In this video, I am going to explain about valency. What is valency? Valency is the number of electrons present in the outermost shell of an atom. Outermost shell. That outermost shell is also known as valence shell. If the number of electrons are 1, 2, 3, then it is metal. If it is 4, 5, 6, 7, 8, then it is non-metal. Okay, so if in case of metals I am talking, if the number of electron in the outermost shell is 1, its valency is 1. For example, sodium has valency 1 because it has only 1 electron in the outermost shell. Okay, the valency of calcium is 2 because the number of electrons in the outermost shell of calcium is 2, therefore the valency is 2. Okay, in case of aluminium, the valency is 3. It's because the number of electrons in the outermost shell of aluminium is 3. Okay, so like this it is here. But suppose if it is 4, in case of carbon 4, so how to determine the valency, okay, of non-metals? I just now told you that, okay, if the number of electrons in the outermost shell is 4, 5, 6, 7, 8, then it is non-metal. So we subtract 4 minus 8. How much it comes? 4 minus 8. So it comes to be minus 4. This minus sign indicates that it is a non-metal, and the 4 indicates its valency. Okay, if it is 5, then we subtract 5 minus 8. 5 minus 8. So it is minus 3. Okay, so the minus sign indicates that it is a non-metal, and 3 indicates its valency. And what about if the number of electrons present, okay, is 8? So in this case, the valency will be 0 because 8 minus 8 is 0, and all the inert elements, okay, except helium has 8 electrons in the outermost shell. Helium has 2 electrons in the outermost shell, even though it is an inert element, and this valency is 0. It's okay. Sodium, not sodium, but metals always loses electron. But exception is hydrogen, which is a non-metal, which also loses electron. Okay, and it forms H plus, hydrogen plus sign. It's okay. And hydrogen also accept electrons, but none of the metal except this electron. None of the metal, they always lose electron, therefore they form positive ions. Metals form positive ions always, but hydrogen forms, it is a non-metal, but it forms positive ions. Non-metals forms, by gaining electrons, and they form negative ions. Okay, the negative ions it is here. Now oxygen is ready to, it has 6 in the outermost shell, so it accepts 2 electrons to make it 8, or you can call it octet. So its valency is 2. Valency of oxygen is 2, right? So valency is the number of electrons present in the outermost shell, and just now I told you how to determine it. Now, in case of sodium, potassium, silver, and copper, the valency is 1. Okay, valency of sodium is 1, potassium is 1, silver is 1, copper is 1. Copper has one more valency. It is copper valency 1 and 2 also. Copper has 2 valency. Okay, copper 1 has 1 valency and copper 2 has 2 valency. Okay, so they are known as monovalent. Monovalent means valency 1. Some elements, okay, are having divalent, means valency 2. For example, you can say about the metals, you can say magnesium, calcium, zinc, iron, copper. Copper has 2 valency also. Okay, so we write Mg plus plus or calcium plus plus or 2 plus. The sign of plus indicates that it is a metal and it has lost 2 electrons. If it is 2 plus means it has lost 2 electrons. If it is 3 plus, it means it has lost 3 electrons. But there cannot be a plus 4. So right, there cannot be 4 because 4 electrons cannot be lost. Okay, and they are not even metals it is here. Now aluminium has valency 3, iron has also valency 3. Iron has 2 valency, one is valency is 2, other is valency 3. So iron which has valency 2 is known as ferrous, and iron has valency 3 is known as ferric. But now this trend has now been changed, it is here now. Now we call it iron, iron 2 and iron 3. Iron 2 means valency 2 and iron 3 means valency 3. Okay. Then some non-metals have also valency 1. For example, hydrogen, hydride also. Okay, hydrogen is H plus and hydride is H minus. Just now I told you that hydrogen is a non-metal, but even it can lose electron and gain also electron here now. In hydrogen, the electron has been lost on. In hydride, electron has been gained. So it is plus one and this minus 1. Now chlorine, bromine, iodine and statine, so they are known as halogens, and the valency is 1. Okay, valency 1, so they are the non-metals, so the valency is 1. Okay. Oxide has valency 2, minus 2 it is here, but the valency is 2. This minus sign means it is a non-metal. Sulfide has valency 2 plus, sulfide is. Then nitride, it is N3 plus. Okay. Now, so this is all about monoatomic elements it is here, or monoatomic ions. Now, polyatomic ions like ammonia, NH4 plus it is, NH4 plus. Okay, one thing here, just keep in mind that ammonia is a non-metal, even though its valency is 1, because it loses electron, NH4 plus. Then hydroxide, OH, its valency is 1. Okay. Then nitrate, NO3. Then hydrogen carbonate, HCO3, hydrogen carbonate. Okay, we also used to call it bicarbonate. Okay, we also used to call it bicarbonate, but now this is known as hydrogen carbonate. Now then it is carbonate. Carbonate has valency 2. Then sulfide has valency SO3. Okay, SO3 is valency 2, and sulfate SO4 has a valency 2. Okay, and the phosphate PO4, okay, minus 3, PO4 minus 3 it is. So I have explained what is valency here. So valency helps in writing chemical formula. So just now I'll teach you how to write chemical formula of some simple compounds. Okay, first compound that I'm going to write is ferric oxide. Ferric oxide means it has Fe and O. So, okay, ferric means the valency of iron is 3, that is known as ferric, and the valency of oxygen is 2. Okay, so the valencies are exchanged. the valencies are exchanged, it is here. So it will be 2 and O3. It is like this ferric oxide. Just you can see, this is ferric oxide. Fe2O3, it is ferric oxide. It is so just like valencies. Okay, the valencies are exchanged. The valency of iron has gone to oxygen, and the valency of oxygen has gone to iron. Now the next one, write sulfuric acid. Next I will write sulfuric acid. Okay, sulfuric acid. So the sulfuric acid, so valency of sulfuric acid is H2SO4. The valency of hydrogen is 1 and the valency of sulfate is 2. So therefore the valency of sulfate has gone to hydrogen. So that is H2SO4 and the valency of hydrogen is 1. So hydrogen 1 is not usually written. So that is, so it is H2SO4. This is H2SO4. So okay, so this is valency of, this is sulfuric acid. Then it is, then nitric acid. Nitric acid it is. Nitric acid is nitric acid. Nitric acid. Okay, it is HNO3. HNO3. You know, the valency of hydrogen is 1 and nitrate is 2. And nitrate is 3. It's okay? The valency of hydrogen is 1 and nitrate is also 3. So it is simply HNO3. Just you can see here HNO3. It's like this HNO3. It is HNO3. Okay? Yeah. Now let me write, okay, calcium phosphate. Calcium phosphate. Calcium phosphate. Calcium phosphate. कैल्शियम फॉस्फेट, ये सब इस फिगरे में आ गया है. Calcium phosphate. Now the calcium phosphate. So calcium phosphate it is, the valency of calcium is 2 and the phosphate is 3. So the valency of phosphate has gone to calcium and the valency of calcium has gone to phosphate. So Ca3PH4 whole twice. It is like this. Look here. See. This is calcium phosphate. It is okay. Now, so simply the valency, you'll have to learn the valency before writing chemical formula. This is important one. It is here, and the valencies are always exchanged. So valency, okay, I'll always extend. It is like this. It is in this way. It is here. Valency of, okay, the first one will go to the second one and second one will go to the first one. It's like this. So valency. Now let me write one formula more here. So it is aluminium chloride. This is aluminium chloride. Aluminium chloride. You know, aluminium chloride, AlCl3. Okay. You know, valency of aluminium is 3 and the chlorine is 1. So it is simply AlCl3. The valency of aluminium has gone to Cl, this chloride, and the valency of chloride has gone to aluminium. Usually we don't write 1. So this is the valency of, this is the formula of aluminium chloride. It is. So okay. So you have to write, you have to learn some valencies of these elements, or the polyatomic ions or monoatomic ions. So this is all about. I'm going to explain how to write chemical formula of simple compounds. Okay, simple compounds. So first I will choose water. Chemical formula. Chemical formula. Chemical formula. of simple compounds. Chemical formula of simple compounds. Okay, so let me choose first of all water. Let me choose water. This is water. So while writing the chemical formula of water, we must know that what water contains. It is which element water contains. So water contains hydrogen and oxygen. Okay, so why there's 2 hydrogen and 1 oxygen? Okay, so the reason is like this. It is so we must know the valency of hydrogen and the valency of oxygen, then only we can write the formula of compounds. The valency of hydrogen is valency of hydrogen is 1. So valency of oxygen is 2. Clear? Then we interchange the valency. While writing formula, we interchange the valency. How? Look here, this is HO. So the valency of hydrogen will go to oxygen, and the valency of oxygen will go to hydrogen. It's okay. It is H2O1. It is now. So usually we don't write 1. So it becomes now like here H2O. This is the formula of water. So okay, clear? So this is formula of water. Now next simple compound is carbon dioxide. This carbon dioxide. Carbon dioxide. This is carbon dioxide. So formula is just like this. Carbon dioxide. Okay, why it is CO2 it is here. Okay, so in the same way we have to find the valency of carbon. Valency of carbon, valency of carbon, it is 4, and the valency of oxygen, it is 2. Okay, so while writing the formula, we usually interchange the valency, very well. So write here CO here now. So valency of this will go to here now. This is 4, and the valency of oxygen will go to carbon. This is like this, C2O4. Not here, but this can be simplified here. How? 2 to the 4. It will get cut here now. So 2 to the 4. So the ratio is 1. The ratio is 1 is to 2. Carbon 1 and oxygen 2. So it becomes now CO2. So this is the formula of carbon dioxide. Is it clear? Okay. Now the next I will teach you to write calcium carbonate. This is calcium carbonate. Calcium carbonate is okay. The formula is CaCO3. This is calcium carbonate. So why it is CaCO3? Okay, so let me tell you, the valency of calcium. You'll have to learn the valency. Valency of calcium, it is 2. Okay, it is valency 2. The valency of carbonate, this is carbonate, it is 2. It is a compound radical. It is monoradical. Okay, it is a you can say it is polyatomic radical. It is here now, because this is carbon and oxygen are there. Okay, so the valency of carbon is 2, Valency of carbonate is 2, it is here. In the, there is a carbonate, we write here -2 here, and here we write +2. In the book we will find, okay, ions, okay, having valency 2, and this is also valency 2, it is here. This is also a polyatomic ion, it is. Okay, so now look here. So calcium carbonate. So calcium carbonate is calcium and the carbonate. It is like this. It is this. This will remain together. Okay, you cannot separate oxygen from carbon because this is carbonate. It's okay. So the valency of calcium is 2. So write here 2. Write 2. And the valency of carbonate is, this is 3 here, 3. Valency of carbonate is also 2. So write 2 here. So look at 2 and 2 will get cut here. So in the simple ratio, so that will become calcium CO3. This is calcium carbonate. So this is the answer. It's okay. Did you follow? So like this it is. Now next I will teach you aluminum carbonate. It's okay. Aluminum carbonate. I will teach you aluminum carbonate. Now this is aluminum carbonate. Aluminium carbonate. It's okay. The formula is Al2CO3 whole thrice. This is aluminum carbonate. So why it is like this? So you know, valency of aluminium, you can write here +3. It is 3 here. Okay, the power, the positive power, it shows that this positive means it is a metal, and this 3 means it can lose 3 electrons. Therefore the valency is 3. Okay, it can lose 3 electrons from the outermost shell. Therefore this valency is 3. Now the carbonate, valency of carbonate. Valency of carbonate, you know what is -2, it is here. It is 2. It is 2. Okay. Then write here aluminum carbonate. So aluminum carbonate, it is like this. So the valency of aluminum will go to carbonate. Look here, it is like this. We write like this. In the bracket, we cannot separate carbon from oxygen. Therefore, it is carbonate. And the valency of carbonate will go to aluminum. So it's like this. So this is the formula. It's okay. So this is the formula. Sorry, it is same. A2CO3. This is the formula. Aluminum carbonate. This is aluminum carbonate. This is aluminum carbonate. Right. Now the next I will teach you to write sodium hydroxide. It is sodium hydroxide. Okay. Sodium hydroxide. The formula is NaOH. This is sodium hydroxide. Isn't it here? How to write it here? Here, the valency of sodium. Valency of sodium. Na plus. This is plus means it is a metal, and its valency is 1. It is 1. And valency of hydroxide, this is hydroxide. Okay, the valency minus sign 1 means it is a negative radical, this is a positive radical, it is also 1. Therefore sodium hydroxide will be written like this, sodium hydroxide. So the valency of sodium will go to hydroxide, and the valency of hydroxide will go to sodium. So like a 1 get cancelled, and the answer is NaOH. This is sodium hydroxide. Clear? Right now. Now I'll write Next, if I write magnesium hydroxide, it's okay. Magnesium hydroxide.